Okay, so now I would like to introduce the first speaker that doesn't need much of an introduction for most of us. He's currently working as a principal Swift engineer at the browser company. He used to work for the New York Times. He also had experience with Headspace, and he's the co-founder of Pixel. He is also well known from his involvement in the open source tools, and his presentation today will be about developer experience. So, improving developer experience through tools and techniques by Krzysztof Zabłocki.
Hello, Wrocław. Wouldn't be a conference if we didn't have technical issues, so the microphone malfunction is the least I've seen over the years. So today what I'm going to talk about is how can you save hours each week for yourself and your teammates, so how can we improve our day-to-day developer experience. And like I was introduced, I focus on open source. I work as a consultant for a lot of different companies, from Fortune 500 to small startups. And so I get to see a lot of ways people try to approach problems, and I try to find solutions that can be applied across multitude of different domains and sizes of the companies and teams. And I open source as much as I can. So if you ever use one of my tools, you probably can see that the general theme is make your life easier when you have to code in Swift. So whether it's iOS or AppKit or UIKit, doesn't really matter. All of the solutions are pretty much applicable. So let's look at what we want to really solve every day. So in my opinion, improving developer experience is one of the best investments you can make as an engineering team. And I'll get to why with actual math that proves it. But let's start with what good developer experience even means. So first off, what we really want to do is we want to focus on the user or business goals of our products, applications. We want to provide efficient workflows. We want to be engaged with the work we are doing. And we want to work smart, not necessarily hard. And humans make a lot of mistakes. So if we can automate stuff, if we can avoid relying on people, generally relying on people, that's the best, because it's the most fragile part of the system. So how can we actually go about improving developer experience? And there are many different ways to do it. One is to think about app architecture as a whole. How can we make the best app architecture? I did a talk many years ago about good iOS architecture. And I think like it really boils down to making the right decisions easier than the bad ones. Because in big teams, you cannot really overview every single piece of code. So the only thing you can strive for is making the right design patterns just easier to use, because people will always default to the easiest solutions. The other thing is, like, you want to remove as many required manual steps that your developers have to do day to day. Like if you have login forms, entering that data every time they want to test a feature, not very efficient. Workflows and code automation, building developer tools, and shortening the feedback loop. So any kind of change you do, you should be able to get the expected result or verify the expected result as soon as possible. That's the ideal situation. So how can you gauge if you should even invest time in developer tooling? It's not easy, because there is a lot of memes I've seen over the years that say that engineer will spend many hours to optimize like something that takes 5 minutes of work. And most of the times that might not be efficient. So you have to think about it a little different. So first off, when you face a problem, the question that I like to ask myself is like, is this inconvenient just for me? Is this very specific to the kind of feature that I'm working on? Is this something that my teammates are experiencing, or even the whole community? Is this like a common pattern in Swift or iOS that everyone has to deal with? How often does it happen? So is this something that happens once a week, once a month, or every day? And then what's the total time, if I multiply all of those variants, what is the total time per week that I waste or people waste working on this? So a simple example, at the New York Times, we had a lot of third-party tools that we used outside of what Apple gives us. Might be Swift, SwiftGen, Sorcery, Swift Format, SwiftLint. All of those tools probably most of us use. And they add up. So each build would add up about 6 seconds. Doesn't seem like a lot, right? But the problem is that is for every single build in the application, including incremental builds, because usually you set it up as a pre-build phase. So it doesn't matter if it's a clean build or incremental, it will execute every time. So 6 seconds every time. And when I measure, and I like data, when I measure the amount of time I iterate over the code in my project, I would build between 200 and 400 times per day. And 90% of the time, I don't really care about those tools running because I didn't touch code that Sorcery depended on. I didn't really care about linter changes. And so seems like a lot of wasted effort. And we had 30 iOS developers at the New York Times when I was working on this. So if you multiply this, even if you get the lower part of the range, you waste 9 hours per day just running tools that don't actually need to be run. That is quite expensive if you consider the cost of engineering per, an hour of engineer time. So what I did is I took those numbers. I seen that it's like 45 hours per week. So I could hire an extra engineer if I can make it easier. And I basically decided, okay, it is worth investing time into fixing. It's not a problem that 5 minutes of time that someone wastes once every now and then. It's something that constantly costing us money and time. So how can we improve it? Very simple. I moved the pre-processing not to be run with every build, but instead to be a pre-commit, which meant that you would always get it if you tried to commit your changes. So the commits were stable and reliable. You also had a script you could run manually if you modified something that you knew you expected, like Sorcery to generate code, or you wanted to apply formatting. So a single line code from command line would run. You could run. Pre-processing script was shared across pre-commit, manual, and CI. So even if you didn't, even if one of your engineers didn't set up pre-commit correctly, the CI will fail the PR and let the developer know that they need to do it. And I have the exact details how that works, including the script at my blog, so you can find it there. All of this is on mirroring.info, but you have links here as well if you want to take. One of the other common issues and how we can fix them is manual steps. I mentioned this briefly, stuff like entering your login credentials doesn't seem like something you should be doing if you're working on iOS application. Every time having to type stuff in just doesn't make sense, or navigating to a specific screen is very inefficient. So the way I approach this is I use user breakpoints most of the time because they do not leave your machine. They do not generate diffs in Git. So you can set it up once, turn it on and off, and you can basically use that to autofill some fields in your application. And it's very easy to disable, right? So I set it up for different scenarios, and then I turn it off or on depending on what I'm working on, and that in itself lets me run expressions. So with the breakpoints, you can specify LLDB expressions, and those can be literally just filling a text field or changing a variable state to switch how the application works. And if you have a long-running feature, I like to use a build phase prescript that basically means that I can do if mirroring. So I know there's a code path in the code base that only runs for me. Nowadays, I don't use this much, but if you have really long-running features and for some reason you need to merge to main rather than use integration branches, that can be handy. Pretty straightforward to use. Another big issue that I run into in every single project over the last decade is retain cycles. Because once we introduced blocks in Objective-C, people started adding a lot of retain cycles. And it somehow happened that I was the one having to fix a lot of them. So I got very annoyed. And Apple gives you some tools for that. So they give you memory graph debugger plus leaks instrument. But the problem with that is that it requires people to proactively open those tools, verify that there are no leaks, and then fix them. I have never seen a team that actually does that before they publish PRs. So what usually ends up happening is leaks get pushed into the main, then the client has issues, or their the memory size causes the Apple to kill your application, and then we have to fix it. So you never want to get the reports of something like that from the users. You want to catch it earlier. And so I built this small open source tool that is based on a very simple premise. And when you design your systems, when you design your architecture, your application, you can usually say how many instances of a specific type you expect to be alive at one point. So let's say you have like a profile screen. In most applications, you have like one instance at a time that will be visible, or even more so like a timeline view in Instagram. Like you have one main timeline view. So if you ever have more than one instance, it obviously means that you leaked. So there are simple rules you can define. And this approach works in any language, but obviously we use it in Swift and Objective-C, and it's very straightforward to integrate. So basically, the way this works is there's like a counter. I'll show you an integration in a second, but there's like a counter and there are a set of rules. And depending on the open source version is very simple. So it's only based on the actual amount of items that can live. But I like recently built for the browser one that can correlate the lifetime counts with model data. So based on what the application thinks it should have in terms of like how many websites are open, all the stuff, we can correlate that with actual view controller instances. So it can easily be extended to be more powerful. But the nice thing about this is that this limits the amount of diff that happens between where you introduce a leak and when it's caught. Because the Apple one, what usually happens is you get a report from the user and then you have to investigate, and then like the memory graph tool helps you if you do something very easy, like for example, you make a delegate strong. It shows that pretty easily because you get like the actual information. But if you have leaks in closures, good luck. That doesn't really work because it just shows you mangled memory addresses. You still have to basically go and comment out code and hope it's going to fix something. So not very efficient. So the best way to fix it is to limit the diff that you have to process. And the way these tools work is as you develop different features, if there is a leak, there will be like a pop-up in your face saying to you that there is an issue with this class. And so then the feedback loop is much shorter. And the integration is literally just defining the amount of items you expect and then just calling track lifetime. And there is even a danger integration that if you forget to call track lifetime, it will don't allow you to merge your PR. So very straightforward, open source as well. Another issue that is very common is data dependencies. So let's say you follow the best practices in architecture and you define your pipeline for data, like something like this. Like you have raw data provider, then you decode it into some models that your application understands. You convert them into something that the consumer can use, like a view model representation. So that works in many cases, and you can do easy stuff. For example, if you need to write tests for your view model or view controller, or you need to reproduce a specific bug report, it's pretty easy because you just change the converter part into fake model. So you just stop the data. Pretty straightforward. But the problem is a lot of the bugs that we have are not because of static data. I think a lot of the bugs that we run into many times is mutable state. That is the source of evil, I would say, in our code bases. So that's one issue, and the other is like if your backend isn't ready, how do you iterate over the view implementation? And so for me, that's been a problem when we were working on the New York Times application. Our backend were not ready, and we wanted to not be blocked on the iOS part. So we wanted a way to easily load external data. And if it was simulator, I would like the data to be loaded from my desktop folder or desktop file so that I can quickly save it and then get automatically refreshed in the application. And if it was on device, I would like to use something like Dropbox or AWS to host my files and edit them. And the real-time updates component was very important. So I wrote this very simple framework that has like two classes called file watchers, and it obviously works with Objective-C. And there's like a local file watcher that you can use to observe something on your machine when you're running in simulator. And there's a remote one that supports ETAGs and last modified date. And the way this works is you just replace the first part of your pipeline. So the raw data provider that would normally hit your endpoints, you just replace that with file watcher adapter. And then this is how we developed the New York Times application. That is literally how the app looked when I built this. So we had like a massive JSON that was agreed contract between us and the backend team, but the backend wasn't available. And so we had to somehow unblock the team to work on features. So as I modified this massive JSON, I think it was few megabytes of JSON, and I save that file, the application updates immediately. So I could iterate over the UI and I could iterate over all the processing without having to wait for the backend. So we implemented all the view layer stuff, all the application logic. And then when the backend said they're ready, we just verified that they actually adhere to the contract that we agreed on. And so we saved a lot of time then. And if you cannot reproduce bugs because data changes often, which is a case in news applications, it's a case in currency or like stock market or crypto applications, you often have like very often changing data sets, and then you get a bug report, right? So every app has to deal with NS data that comes in at some point, regardless of what kind of application you're working on, that will be the case. And I come up with this simple idea because we were running into a lot of issues with news where every single article could be represented in like 20, 30 different display variations based on the small changes in the data. And usually the way bug reporting works is you would get a bug report and then only a month later you were able to work on it. So if you have a frequently changing data set, it's really hard to reproduce those bugs. So you can have staging environment, and the New York Times did have staging environment, but that doesn't really help if you have 30 engineers that are working on 30 different bugs, and each of them wants different data to be featured. So that doesn't really scale. So instead of that, because that was causing us a lot of headache, I come up with this simple idea. Okay, so if I know that I have raw data in every application, what if I pipe that data through a function? And that I can identify the endpoints, right? I can uniquely identify every endpoint that I'm hitting in most cases. And so I can run the data that comes in from the server through a function, give it an identifier, and then get a data back. And this is really easy to integrate because regardless of your app architecture, you will have a place where you just download the bytes. So you pipe this information into that function, and then you don't use the data that came from the server. You use the data that came from this function. So you just switch, right? You just do this simple pipe, and then you use the data that was returned. And now in production, this is a no-op. In production, what happens is the input is the output. Your application works as usual. But there's behind the scenes, there's a state that we have in this function that defines the type of functionality that it does. So one state is recording and the other is replaying. And the way this works is, as the user is using the application, by default, the data is returned, and then we save all of those raw bytes into a specific folder on disk. And then when the user wants to report a bug, so they shake their phone or they use like a function in the settings to report a bug, we snapshot all of that data, pack it into a zip file, and send it to S3 and generate a unique identifier. We then send that identifier along with the bug report. So when the developer a month later wants to reproduce the bug, they can just go into the application, put in the identifier in the settings, and they will get they will get back the data, and the function will switch from recording to replaying. So now all the endpoints where you were piping through will return a completely different data than what came from the server. So you're wasting a bit of download output because you're still downloading data you don't use. But this lets you verify all the different parts of your code base except for the actual downloads. So you can reproduce bugs at every single layer, which is very powerful. And I have a blog post about this that goes into more details, how to build this. But this is how it worked. So you had this idea of snapshots. And when someone reported a snapshot, you can see at the bottom there is like a snapshot identifier, and you could just load that snapshot in the application. And then we could reproduce bugs that normally would take us at least a few hours to get featured through staging and then dealing with other people wanting to do it. Now we completely eliminated that. And if you need more power, you can leverage something like unidirectional data flow architectures, but that is like a costly thing to do because most applications didn't use that. And you could go even more crazy. Like this is a demo of an application or a framework I built that worked in Objective-C. And there was 2 lines of code in the whole product. And I was able to reproduce all the actions that the user took by recording the actual Objective-C invocations and arguments rather than having like an architectural integration. So I was literally replaying runtime functions, and this allowed me to reproduce bugs. But this is far easier because that was pretty magical, but it's far easier if you have unidirectional data flow, because if you have something like TCA, you can build time travel feature by recording every action that goes into the system and then just replaying it. So pretty straightforward in the architectures that are popular today. But I would be like, this has some concerns. Also, recording has concerns in terms of the kind of data you record. Like, you don't want to persist user data unless it's like a beta group, so they agree explicitly. You don't want to save something that's personal information, especially with GDPR, but it can be useful. Another big issue that people run into is when they want to write tests. This is how Xcode greets you if you do a non-primitive test. So if you compare like an object, you want to see equality of an object. This is the result if it's not equal. For the love of God, I cannot say what is wrong with my object. It's not a very efficient way of writing tests, not very convenient. So there is this simple mini framework that I built that uses mirror, and instead of this bullshit, it just gives you specific details that tell you exactly what is wrong in your object to a primitive level, and it goes over arrays, dictionaries, pretty much everything. And I would say that this is much easier. This is literally a single file framework that you can include, and it doesn't really do any runtime or anything like that. It just uses Swift mirroring. Pretty powerful. Another issue that pretty much every Swift project has run into that I saw is boilerplate code, and the fact that having to write the same code over and over again. It's not really good developer experience. Like, you don't want to repeat the same patterns, because then if you realize there was like a bug in your thinking, now you have to go over every single time you actually wrote it and fix it, and that doesn't really scale. So there's a tool I built called Sorcery, and Sorcery works like a preprocessor. So it runs before Swift compiles your project. And you can think about Sorcery as a function that as an input, it gets Swift. And as an output, it can generate more Swift, or it can generate other stuff. Like, there are people using Sorcery to generate Dart or Kotlin or JavaScript. I'll have some examples. And it's used in over 40,000 apps. Airbnb, Bumble, and a bunch of other big names use it. It adds also annotation support to Swift language. So if you want, like if you are familiar with Java or Kotlin or other languages that let you give extra metadata to your declarations, Sorcery enables that as well, which is most used to allow fine-grained control over the kind of code you want to generate. I wouldn't abuse it, but it's useful. And then if you can describe an algorithm once to a human, you can describe it to Sorcery, which means you can pretty much do anything. And Sorcery can also be used to introspect applications. So oftentimes when I get hired to consult on projects, I want to see, like, you know, how big this project is using in terms of like how many protocols, how many classes, structures. So I can write something like this, and I have like a real-time preview, and I can immediately know whether it's more protocol oriented, it's more of a mutable thing, or a bunch of other information that I can take out of it. But there are more interesting examples. So one of the open source projects that I have is called Automatic Settings. And this is pretty simple to explain. Almost every application that I've seen, iOS application, has some kind of debug settings that are meant for developers and QA. So you usually have some kind of way to access extra hidden features of your application and tweak it. Whether that's resetting your subscription counter, like if you have a meter for like how many, like in the New York Times, for example, the free user can see only n amount of articles. And one of the beta settings is being able to reset that counter. So even if you don't log in, you can get more articles. There's a lot of applications that are using a bunch of different stuff. And so very common pattern used across pretty much the whole industry, and not even iOS apps, but like pretty much all the apps that are like bigger apps. It's not very convenient to have to write this for every client, or it's not very convenient to maintain this. Like if I just want to add a Boolean that I can control as a debug setting, I don't want to go and now I have to write the Swift UI for it. I have to write the data entry. I have to write the persistence. It's not ideal, right? So what I built is using Sorcery and some custom DSL that I built using one of the few of Swift language features. I made it so that if you define the data, if you just define the structure of the kind of data you want, so like here on the left, this is all the code that the developer has to write. On the right, you see what actually gets generated and what works. There's like no manual code required outside of the definition of the data. So the way this works is you simply define the booleans, the integers, the custom custom types you want, and Sorcery will read your structure and generate Swift UI source for it. And the DSL allows you to easily add support for custom types. So if you define a completely custom object, you can specify a pure function, and that pure function will automatically be picked up by Sorcery and used into injecting the generated UI. So very powerful. I replaced, I think, 5,000 lines of code in the New York Times code base with a single PR and just removed it and then used the generated version. And I have this running in few clients projects and works really well, really extensible. And if you get asked to add, okay, I need this new integer that I want to control, like a slider for, like, let's say, perform animation speed, right? You simply define the float, and you just build the project, and it's already there. You can already use it. So it takes you like 10 seconds to write the variable. Pretty convenient. Another example that I built for the Times was A/B testing. They have a custom A/B testing framework. And rather than having to build all the bindings and UI, I basically made it so that in a structure, very similar pattern, in a structure, I can define what kind of A/B tests I want to support. And I just provide the types. So I provide the type for the variants, which was an enum that was just defining all the variants that the app supports. And then from that, I could generate the UI. That would not only allow me to override the A/B test for testing. So if I am a tester or a developer, I want to assign myself into a very specific variant so I can actually work on a feature or test it. And pretty straightforward. This template was like 70 lines of code or something. Pretty straightforward. Another example is when ARKit came out. We wanted to make it easy for journalists to write engaging articles that leverage ARKit, AR experiences. And so I built this framework that worked kind of like a command bus pattern, where you could decide what kind of actions the JS side of things can request. So for example, they could use SceneKit along ARKit, so they can decide which nodes to show or hide, or change properties of visual materials from the JS side. And I use Sorcery to basically, the developer would just define a case. One case was one command. And from that case, it would generate all the boilerplate to translate that into the JavaScript representation that the articles would be calling. And it materialized, I call it materialization. It would materialize the actual data fully typed. So the JS obviously didn't have Swift types. They would just send JSON. But all the boilerplate code that was generated would basically deal with the type conversions. It would auto-report errors. So for example, if they decided that for, let's say, material set properties function, like the last command here, if they use the wrong type for ID or material, like it wasn't a string, it wasn't convertible to string, they will automatically get an error. Or if they misspelled a variable, they will automatically get an error. So the client side didn't have to deal with that. The client, the only thing that you had to do as an engineer is you would switch on the command. And by the time you switch to it, it's fully typed. So very straightforward, very powerful. We actually won Emmys with this framework, building articles with this framework, which is crazy. But yeah, Sorcery limitations are very low. Like you can pretty much build anything you can describe. And a lot of people are worried because it's a dependency. So you don't know if you want it or not. But the truth is that because it runs as a preprocessor and it's not opinionated, you can define exactly how the code will be generated. And at the end of the day, even if Sorcery stops working, you can just go back to manually writing this code. But as long as it works, and it has worked for the last 6 years without any hiccups, you actually save a lot of time. But because people complain, I wrote this application called Sorcery Pro, which comes with Xcode like
Sorcery
templates.
Pro.
Oh my God, I shouldn't have audio here. One second. Okay. So basically, this lets you run Xcode plugins, so like native plugins, and generate code on demand rather than continuous integration. You can run it on demand. So like if you have an enum and you don't have the new Swift, you could generate the codable version, or you can generate protocol mocks and then tweak them manually. You can do a lot of other stuff. Basically, like the problem with Sorcery, like the only limitation with Sorcery is the continuous integration. When you use the command line version, it has to be consistent, right? Every time code changes, it has to change with it. And some things cannot be represented like that, because some things are more like a generator pattern where you want to start with a smart template, but then you want to take it over and own it and modify it to your needs. So this is where the Pro version comes in, because it lets you define templates that will run on your current code, but then you maintain it manually, which is very, very useful, because you can like kickstart Swift UI view from just the structure of the data. And there's like a bunch of templates. I think I bundle like 13 built-in templates with this tool. And there's like a powerful editor as well, which has stuff like inline errors, documentation, IntelliSense, pretty much guides you by the hand to write custom templates, which makes it really, really easy to use. A funny thing, I don't know if people know Sarush, but he's one of the very good engineers in our community. And he told me a story. He went to, I think in Australia, a conference, and he's a fan of Sorcery, and he was speaking with one of the engineers there. And the guy told him that he uses Sorcery in his project, but he doesn't tell anyone. So what he does is he volunteers to take testing tickets and then just runs Sorcery to generate the code and then calls it a day. So now with Sorcery Pro, you can actually do it straight from Xcode. And no one will be any wiser to know that you actually use this tool. And it's available. You can get it on Mac App Store or privately if you have a company. And that, once we define that what Sorcery does, we can talk about testing mocks. So if you have protocols in your projects and you want to write tests, which you should, and we'll have a talk about testing by Paweł. So he'll go into more details. You know that it's a hassle to write protocols and write mocks for the protocols and then keep them up to date. So you have two options that are available straight away. One is Swifty which is also using Sorcery. And it builds, if you use Ossi Mockito or one of the Objective-C frameworks that had this nice verify that something did something DSL, it also does that. Or you can use something simpler, like there's like an auto-mockable template that comes bundled with Sorcery. You can write custom ones, which I'm sure Paweł will mention because he had some really nice ones. And this basically means that every time you change your protocol, your mocks get auto-updated. The other benefit is they're always consistent. So if someone wrote tests in one place of the code base and use the kind of mocks that you had there, they will be exactly the same in different part of code base, which makes just much easier to share knowledge across the team and make it better over time. And obviously, like I mentioned, you can use the live templates. So even if you don't want to integrate Sorcery fully, you can just run the mock on demand. Although for mocks, I prefer continuous integration. And the other issue that it's probably one of the ones that I'm most annoyed about is the long iteration cycles. And this especially got worse when Swift was introduced, because Objective-C compiled pretty decently. But the first versions of Swift, I mean, it got better over time, but it's still pretty slow. So if you have very big projects, your build can take like a minute, 2, or even more. I don't want to get into the scary stories of some of the clients, but you really don't want to recompile if you don't need to. So even if you get an example, and it's not just the recompilation. So think about this, you have time per iteration. So it's recompiling the project, whether it's incremental, obviously, ideally incremental build, but then also getting into the exact same state you were before. So let's say you're working on a specific screen in your application. And that screen is like 3 levels deep. And it requires also, like what you're working requires entering some data. So you have to recompile, you have to run it on simulator, so restart the application on the simulator. Then you have to click through to get to the 3 level deeps, and then you have to enter some text field. That is a lot of time. Most of it is not even spent recompiling. But let's assume it's like 25 seconds. I mentioned I got between 200 and 400 iterations per day. So let's assume you have 300 iterations. That's 2 hours that you are not actually doing your job. That's just, well, that is just wasted, right? You could have been writing code, you could have been having fun or whatever. At least doing something productive. Watching a spinner or clicking the same buttons over and over again, it's not very productive in my book. So it's 3 hours or 2 hours, depending on the amount of time you spend, wasted. The other thing is it causes a disconnect. So if you're working on UI or UX, you want to have as fast feedback loop as possible. That way you will tweak the interactions and the animations to make them feel the best. If every time you tweak the animation value, you have to restart the application, I guarantee you that you will not try as many as you would otherwise. It's just getting annoying very quickly. So there are a few ways you can improve it. Like you can split your project into many different modules. You can use small preview apps. This has benefits, like you should do it even outside of the point of iteration cycle. It just improves the architecture design because it forces you to define public and private properties correctly, which is always nice. But each framework also can have a quick test suite. Just a lot of benefit. Just modularize your apps. That's basically it. You can use playgrounds. I am yet to see a very sensible and stable playground use in big applications. Swift previews simply don't work correctly in any medium-size applications, so I do not recommend them. First, like the way I approached this problem first was I built this tool called KZ Playground, and I built this back in when Swift 1.2 was introduced, and I built it for Objective-C because people are saying like, oh, you can only do playgrounds in Swift. That's why they came up with a new language. It's like, no, like I've been using this for years and you can easily do it with Objective-C and works better. And it has like custom DSL for exposing controls and had interactions because back when the playgrounds were introduced, you couldn't actually move views. You couldn't interact with anything, right? It was just all static. And it was pretty straightforward to add it to existing code base. And it worked with this tool called Injection for Xcode, which is like a Mac tray menu bar application that runs and integrates with LLVM, so it doesn't require you to unsign your Xcode or anything crazy. It's totally safe. This is how it looked like. So you had like on the left you had a timeline view, on the right you had a workspace, and then you could just modify the code. And the moment you save the file, the code would be injected and refreshed. It was much faster than Swift playgrounds, where I think they still are slower than this. But this required iPad version. It required a lot of integration. So over the years, even though I used it, I saw there was like a lot of friction to get people to use this kind of tool. So I had other idea, like how can I get the essence of how this project works and make it as easy as possible. So what if I told you like you only need to change 2 lines of code at the most to get live reload or hot reloading in your Swift UIKit, AppKit, tvOS applications. So rather than just creating a view controller, what if you just wrap that view controller in another class? And the moment you do that, you can actually do live reloads, right? 1 line of change, and including the framework, obviously. And now you can iterate quickly. So this is basically how it works. Like there's like 1 line of code that changed in this project, and it now allows you to live code the whole screen. So you can do any changes, and it doesn't really matter if you're using Swift UI, AppKit, UIKit, tvOS. If you can run it, it will work. So that's pretty cool. And that's an example of UIKit application. For Swift UI, there's one more thing. Like you do it a little different. So you basically, what you do is you just create a private variable that is a published object. And then at the end of your Swift UI definition, you just call enable injection. The nice thing about both this and the previous code changes is that in release, this code is actually no-op. So it works in debug when you are developing your application, but you don't have to remove it. You don't, at least like the Swift UI stuff, you never have to remove it. I had this running for years in projects. What it happens is it's all if-deft, and this like enable injection, for example, just returns self. And so the compiler can optimize it out because it sees that it doesn't actually do anything. So this code, when you define your views, you just set it up once. And then the moment you set it up, you just leave it there for the next developer. And that enables you to iterate over everything without using Swift previews, without using playgrounds. Pretty much free improvement to your workflow. And this is an example of Swift UI application that is using this. And you can see that you can just comment out code and you'll get updates in real time. There's a lot of benefits to this. First off, use your production data. You don't have to create fake data just to work quickly like you do in Swift previews. You have full debugger support. Furthermore, all the changes that you do, if you put a breakpoint, that breakpoint will actually work as expected. So if you add new code and you put a breakpoint on new code and you save the file and that code gets executed, your breakpoint will stop. So you use the same kind of workflow you would use normally. There's no special handling. There's no crap like that. So extremely, extremely powerful. And this is available for everyone. It's a free, both the inject and injection for Xcode available. You can get it from App Store, but I recommend getting the GitHub version because we are constantly updating the injection for Xcode with future improvement. But this tool has been available for like 8 years, so it's very stable. It works way, way better than Apple tools, and it just makes it easy to hot reload for both Swift and Objective-C. And there's no runtime. There's no like magic supported. This actually works as an LLVM interop, so it integrates with LLVM process. It can also be integrated, like the inject can be integrated as a SPM package. And like I said, in prod, it doesn't actually require you to remove it. Once you integrate it, you can just keep it. It costs nothing. There's no performance cost. There's no fragility to it. If you don't use injection, it will just not do anything. So it's all opt-in. And to summarize, creating a good developer experience, in my opinion, is one of the best investments you can do. And when you're defining a new application, you're trying to think about the architecture, consider how your developers day-to-day will work. Like if you're creating an architecture that will require a lot of manual steps or a lot of boilerplate, like for example, Viper has this tendency to require a lot of different files to be created, to the point that last I checked, there were like 2 code generators just to get the files for Viper. To me, that is, unless you actually have the needs for it, like you're at the scale when you have hundreds of developers, I would probably say it's an overkill. And the nice thing is, the time that we invest into improving our developer experience is actually a massive return of investment. Like this is how I made my living for many, many years, is I can go to a company for like a month and I can improve their developer efficiency by many, many times. And if I can do that, then I can charge good rates and I can get a win-win situation, because every developer benefits, the company benefits because they can work faster and focus on the stuff that matters. And I just make an impact. And the other thing is, I just realized many years ago that as good as you can get as a single engineer, you only have 24 hours in a day. So just focusing on your own work doesn't scale. Like the ceiling is very clearly visible. It's easy to reach. But if you become a multiplier for everyone else in the company or the team or the community, then you can make a massive impact without having to sacrifice your life and working 16 hours per day. So let's focus on how we can make the business goals and user experience better by just taking away all the unnecessary stuff that developers do every day. And if the 10 developer exists, which I am very skeptical about, it would not be a genius sitting in a basement that can just crack any algorithm. It would be a person that just empowers everyone else in the team. But remember that when you consider whether something is worth investing your time into, like dev tooling or framework or whatever, you have to ask a bunch of questions I started with. I think this is really important because there have been a lot of tools that I built over the years that I have never open sourced, because once I wrote them, I realized, okay, the integration is too hard, people won't use it, or it doesn't really scale, it doesn't solve big enough problem, it's not common enough that people are facing this. So it's always a question of balancing out, like what is the actual use cases, how many times people have need for this. Because if you create tools and no one uses them, it doesn't matter how great the tool is on paper. If it's not adopted, then it's useless. And consider getting Sorcery Pro to automate your workflows and use Inject. I highly recommend you try this. I mean, this is by far the most useful thing I did over the last decade in terms of what I personally used as an engineer, because the amount of time it saves, like there is obviously to every new tool, there is a cost in learning it, but I highly recommend you at least spend a few hours playing with it, because it works more often than not. It's not ideal like everything, but it is so good. Like everyone in the browser company loves it, and other clients that I worked with, when they see what's possible, like their minds are blown. So hopefully you'll try it and let me know if you run into issues. Always happy to help. And thank you. And I think we have some time for questions. 5 minutes, yeah. Any questions? Yeah, go ahead. Yeah.
1, 2.
Thank you very much. So you were talking about Inject and how it's very easy to integrate at just 1 or 2 lines of code. But if I want to do this at a big scale on a big team, did you try to do it with Swift Swizzling maybe? So I can automatically provide this to a team of 100 developers without nobody having to add any single line of code.
Yeah. So if I understand correctly, like you're asking if we considered automating it by like swizzling the implementation. I don't really like swizzling. I especially don't like swizzling by external parties. So like a lot of analytics libraries do this, where they swizzle a bunch of code under you, and then you don't really know what they are doing, and then there's potential issues there. So the tool itself, there's like it can inspect the code, like the injection for Xcode. It can generate the code for you to get you started for like Swift UI side of things. I prefer opt-in. I mean, it's literally just adding 2 lines, and you could write a script with Sorcery, for example, that will find all the Swift UI classes and do the injection stuff. But yeah, I'm like, I don't want to modify code that the people didn't ask to modify. Just from my personal experience, I'm not very high on doing that. Any other questions? Yeah, one more question. Yeah, thank you.
Thank you very much.